Hello, this is Mrs. Carpel, and this is part 3 of topic 1.7, rational functions with their vertical, horizontal, and slant asymptotes and holes. This particular video is focused on the slant asymptote. How do I know if I have a slant asymptote for my rational function? Well, if the degree of the numerator is 1 greater than the degree of the denominator, then the rational function has a slant asymptote. So only when the numerator has 1 degree greater than that of the denominator will you have a slant asymptote. So we have a graph here, and you'll see we have a vertical asymptote, and then you have one that looks like it's slanted. That is the slant asymptote. So this dashed line, oh, I want my other highlighter. This dashed line is what we call the slant asymptote. So our function will get closer and closer and closer, but it will never actually cross it. So this is the graph of the function k of x equals x cubed minus 4x over x squared minus x minus 2. In its factored form, the numerator is x times x minus 2 times x plus 2, and the denominator factors as x minus 2, x plus 1. Because the numerator and denominator have the factor x minus 2 in both of them, we know we're going to have a hole at x equals 2. We know that because we also have the factor x plus 1 in the denominator and it does not occur in the numerator, that we're going to have a vertical asymptote at x equals negative 1. To get the equation of the slant asymptote, we're going to do long division. So just let me show you how we do long division. I'm going to start with some numbers first, and then I'll go into a polynomial, and then we'll do an example where we will find the various asymptotes and find our slant asymptote. So when I have just numbers, I'm going to divide 676 by 21. So that 21 is my divisor, I believe it's called. 676 is my dividend, I believe it's called. And I am going to look at the first 2 digits of 676 and ask myself, how many times does 21 go into 676? That's going to be 3 times. 3 times 21 is 63. After I multiply that, I find the difference. 67 minus 63 has a difference of 4. And then I need to bring down the 6 and repeat the process. How many times does 21 go into 46? That's 2 times. 2 times 21 is 42. Again, I'm going to find the difference. And my remainder is 4. So my quotient is 32. My remainder is 4. And I can write this answer as 32 plus 4 over 21. Or I can just write it as the mixed number, 32 and 4/21. Long division with polynomials works the exact same way. So I have my divisor, my 2x plus 1. I have my dividend, 6x squared plus 7x plus 6. However, I'm only going to look at the first term. I'm not going to look at the two of them together. I'm going to look at the first term and think about what I need to multiply it with to get the first term of my dividend. 2x times 3x will give me 6x squared. So I'm going to write that 3x directly above my 7x because they're like terms. I'm going to keep them lined up. 3x times 2x is 6x squared. But I'm also going to take that 3x times my constant, my 1. 3x times 1 is 3x. Just like I did with my numerical long division, I now find the difference. 6x squared is going to cancel. 7x minus 3x is going to give me 4x. And I bring down my 6, my plus 6. And I start over. What do I take times 2x to get 4x? That's 2. So we have 3x plus 2. 2 times 2x is 4x. 2 times 1 is 2. We find our difference. And we have a remainder of 4, much like we had with our numerical long division. So our quotient is 3x plus 2. Our remainder is 4. Because it is a polynomial, I'm going to write my answer as 3x plus 2 plus 4 over 2x plus 1. But there's only part of this answer that I'm really interested in when it comes to finding my slant asymptote. The 3x plus 2, I want to put a shape around it. My 3x plus 2 is my slant asymptote. So this value that I've just boxed is my slant asymptote. I don't need to do anything with my remainder when I am just trying to find my slant asymptote. So I'm going to go ahead and move to example 7. The reason I'm choosing example 7 is just to review the vertical and horizontal asymptotes, as well as finding the slant asymptote. So we've got the function g of x equal to x cubed plus 4x squared minus 12x, all divided by x squared plus 7x plus 6. Directions are find the equations for any asymptotes to the graph of g of x. So let's first factor this. I notice that my numerator has a common factor. So I'm going to factor out that common factor right now before I go any further. So that's going to leave me x squared plus 4x minus 12. Then, for my factored form, I have two trinomials that I'll be able to factor. My factored form will be x times x plus 6 times x minus 2, positive 6, negative 2, multiply to give me negative 12, positive 6 minus 2, add to give me the 4. My denominator will factor as x plus 6 times x plus 1. Now for my, if I were looking for holes, that would happen at x plus 6. So when x is negative 6, we're going to have a hole. I'm just going to add that here as an additional piece just because we can. So we know we have a hole at x equals negative 6. If I put negative 6 into the remaining value, into the remaining factors, we're going to have negative 6 times negative 8 is 48. And negative 6 plus 1 would be negative 5. So negative 48 fifths, which would be negative 9.6, would be the actual location of that hole. Now, factored form, if I wanted simplest factored form, I can go ahead and I can remove the x plus 6 factor. My factored form is going to be x times x minus 2 divided by x plus 1. In this form, I see that I still have a vertical asymptote at x equals negative 1. Because the degree of my numerator is more than the degree of my denominator, I do not have a horizontal asymptote. But because it's 1 degree greater, I know I do have a slant asymptote. And to do that long division, I'm going to use this simplified form of my function. I'm going to go ahead and take x times x minus 2 for my dividend. So that's going to be x squared minus 2x. And then just to continue down that standard form, I'm going to put a plus 0 as my constant on the end. Anytime you're missing one of the terms, you want to put a placeholder with a 0 there. And we're going to divide this by x plus 1. To get x squared, that's going to be x times x, so x squared. X times 1 is a positive 1x. But then I go and I find my difference. I subtract all terms that I just multiplied or that I got as the result of my multiplication. So x squared cancels. I now have negative 3x. And I'm going to bring down that 0, that placeholder. So now I see that I need to take x times negative 3 to get negative 3x. 3 times x is 3x, or negative 3x, excuse me, because I'm taking negative 3 times x. And then negative 3 times 1 is negative 3. Then I find my difference, which changes these two positives, and I'm going to have a remainder of 3. Now, I'm not concerned with that remainder because the only information I'm interested in is this x minus 3. And to write it as the equation of that line is going to be y equals x minus 3. I also want to take a quick moment to look at example 8. They have the numerator factored for us. We need to determine which of the following statements about the graph of d of x is correct. So I'm first going to start with factoring that denominator, see if I have any common factors with the numerator. And I have x minus 1 times x minus 1. Now, one would think that, well, I'm going to have a whole at x minus 1. True, that could be a whole, but because only one factor of x minus 1 is common, the vertical asymptote actually takes precedence. So we are going to be able to say that there is a vertical asymptote at x equals 1. The degree of my numerator, if I take 2x times x times x, that's 2x cubed. There's no horizontal asymptote. But because the degree is 1 greater than the denominator, I know I'm going to have a slant asymptote. So if I look at these statements, the first two say there's a horizontal asymptote. We can rule them out. The next two each say that they have a slant asymptote, but the C says that there's one whole. Well, if you have a vertical asymptote at the same value as a whole, the vertical asymptote is going to take precedence. So there are not going to be any wholes in this particular function. The correct answer is D. So hopefully you've understood how to do the long division to find the slant asymptote. That you understand that a vertical asymptote will supersede or have precedence over a whole at the same x value. And if you're going to have a slant asymptote, you're not going to have a horizontal asymptote because that degree in the numerator is larger. And this concludes my material for topic 1.7.